Reviewing what we did yesterday. You don't need to write this down. However, it might be better and easier to understand now that it's incubated. Stop talking. Stop making noises. Okay? To review what we did yesterday. We have A plus B, correction, yesterday we did subtraction. A minus B is equal to A stays the same sign, whatever A is, for any value A. A stays the same. Then we flip the second sign, and also we flip the next sign. So if in this situation, B is a positive 7, so I have A minus 7, what is it going to be over here? Did I say? Yes. Okay, yeah. A plus negative 7. However, what if that's the situation? Yes. A plus the positive B, which is the same as A plus B. Okay? It's flip both signs. We are flipping not only this sign, but whatever the sign of B is. So this was flipped, and that was flipped. Okay? Now that it's incubated, does that oh, well, why didn't we learn that yesterday? And I'd be like, we did learn that yesterday. Okay, we are recording. All right. Moving along, we did addition. We did subtraction. And then what do you learn next in school typically after addition and subtraction? Multiplication. Beautiful. So let's learn multiplication. Multiplying integers notes. And let's do a shout out to somebody. Let's see, who has a dog? Okay, Quinn, your hands was up first. What's the name of your dog? Jesse. How does Jesse spelled? Okay. All right. Yep. So here's Jesse's notes. Multiplying with counters. Using the example of 2 multiplied by 4 to illustrate the problem using counters. This means 2 sets of 4 integers. 2 sets of 4 integers. Do you agree? Do you agree that that's math? It is continuous addition of groups. 2 sets of 4 integers. Or 2 groups of 4 integers. And that's what's illustrated here for the first one. We have one group of 4 and another group of 4 being added, and that's going to have 8 positive integers. So that comes out to be 8 integers. Those arrows indicate what movement is happening. It's being introduced to the mat. Yeah.
Okay, how do you know which one is going to be the one that you're multiplying?
The first one, well, actually, you can have it be whatever because of the commutative property of multiplication. You could also have it be 4 sets of 2 integers.
Okay, so it doesn't really matter.
Nope, because of the commutative property of multiplication. On number 6 on the back side, when we're doing the examples, for the notes, you'll see how that could come in handy. Okay. So for the little lines here, I want you to write down one of the rules with math. The product of 2 negative integers. Let me back out a little bit. 125. There we go. The product of two negative. Did I say negative? I'm sorry. Those aren't negative. Positive. Good thing you're using pencil, right? Yes, because you can erase that. And you're also going to get this tomorrow, but this is a way to make sure that you guys are doing it correct, so you can check yourself so you don't get them wrong. Because we don't want any mathematical wreckage. The product of two positive integers will always be positive. Always be positive. Sir, yes? Yes. Someone who can write pretty fast, would you mind? You're good. You're good. Now it starts to get a little bit more complicated because we're starting to get negative integers in there. Multiplying with counters, using, for example, 2 multiplied by -4 to illustrate the problem. So this one's done for you, and there are 2 sets, that's not hashtag, 2 sets of -4. 2 sets of -4, and that comes out to be a -8. And to check your work when we're doing this for homework tonight, you can make sure that you have the right sign by recognizing this. The product of 2 integers with different signs. Different signs. Whoa. The product of 2 integers with different signs will always be ring. Negative. Liam. That's not... What? You don't go by Liam? You go by Chase. That's your middle name, isn't it? Wait. Okay, sorry. Okay, see, I called Peyton Jordan a little bit ago because I'm learning your guys' names and I'm testing myself. Okay, there we go. Chase. Yes, you are correct, which is exactly what you just wrote down. Yep, good. Yep, that's good. That will continue for all of your mathematics to remember that. Next one, multiplying with counters, having both negative numbers to illustrate them. So we know that we're going to be ending up with a positive from what we wrote on the other page. And this is like saying, since we have a -2, you don't have to write what I'm going to write. Question? Not during the passing period. There's something about noise being outside that kids have to use the restroom. No, wait until the 8th graders are done. So I'm going to rewrite this. You do not have to rewrite this. I'm just doing this so I don't have to sit on the floor and write this. So we have -2 multiplied by -4. Is that right? Yes, it is. Okay. So, Let's do this. Write this. When both are negative, do you know what I mean by both? What am I referring to? What is it? Both the numbers, both the integers. Yep, both the integers. Is that what you're going to say? Good. When both the integers are negative, make a C of zeros. Picture frame so I remember it. Yes, sir. It's sometimes when you push this button, it makes noises. So when both are negative, make a C of zeros. So what negative 2 multiplied by negative 4 is actually doing is telling you to remove, which is a negative, right? Remember how when we subtract stuff, we remove stuff? And the negative symbol is also a subtraction symbol. So you can think, okay, I'm going to remove stuff. So I'm going to remove, which is a negative, I'm going to remove 2 sets of what? 2 sets of what? What am I removing? Nikolai, do you know? True, they are circles, but keep going. I'm trying to. How many of those negative circles? Yes, there we go. Okay, 2 sets of negative 4 integers, or circles as Nikolai liked, which is true. So this is the act of, what color did I use last period? It's green. This is the act of removing 2 sets of negative 4 integers, which would leave how many integers of what sign hanging out at the party after those ones left? Schaefer, do you know? If these 2 sets of negative integers left the party, who's left? Who remains at that party? 4? Think about what isn't circled. 8 positive, right? Yes, it is 8 that are left. So we are left with 8 positive integers chilling at the party. Yes?
So the 2 negative signs of multiplication, differentiate, and then the answer is positive.
That's a great observation. You are completely correct. Make sure, Tamaya, right? That's how you pronounce it? Okay. Because there's, last period, I do absolutely horrible with pronouncing Zaya and, I don't know, whatever. Okay. Yes, because of this. The product, with 2 positive integers, you know what? We could even change that to the same integers. The same sign. Let's do that. The product of 2 integers, I thought that's what this said, I didn't realize it, with the same sign. The product of 2 integers with the same sign will always be positive because it creates a double negative and then a positive that becomes even more positive. The product of 2 integers with the same sign will always be positive. Yes, sir. Yes, sir. Would you mind if he doesn't get back? Go ahead. Go ahead. copying down stuff that we do. Yeah. All right. Boy, it is warm in that hallway. Ugh. Yeah. You're welcome to wear a tie and pants. I invite you to do it. You'll feel like $1 million. Okay? Examples. Use multiplication mat and your positive and negative symbols to draw a series of illustrations to show your work. I'm going to choose red as negative, and I'm going to choose a much lighter color. See if you guys can see this. Can you see that at all?
Yeah.
Blue is going to be positive. Does it show up better on YouTube? Oh, it shows up a lot better on YouTube. Okay. That might be too light. I'm going to go purple. All right. This first one is telling us that we are going to be having 3 sets of 3 integers. 3 sets of 3. That's all I need to write. 3 sets of 3. Positive. 1, 2, 3. Three sets of 3 positive integers. And how many people are at the party in the map? There's 9 there. There's 9. There's an ugly 9. That's a depressing 9. Whatever, here. All right. Any questions on that one? Okay, we have 2 negative symbols, and because I remembered the rules by it so I can double check myself, I know that this is going to be a positive product. So I'm going to put a little plus up there so I know that when I'm done I'm not making a mistake. There was somebody in this class who missed, because we were using mats, 9 plus 2. Because we were using the mats rather than thinking about double checking ourselves, but it's easy to make simple mistakes when we're trying to do it this way. So this is telling us that we need to take away 2 sets of negative 3. So there are 2 negatives here, and if I remember right, hey, when both are negative, make a sea of zeros. So I'm going to be here, and I'm making a sea of zeros. I'm going to make 2 sets of 3 zeros. 1, 2, 3. 1, 2, 3. Because both are negative, and as we wrote down and put a picture frame around, what was red positive or negative? Yeah. Gabriel, turn around. So it's telling us to remove 2 sets of negative 3. That's what it's telling us. The remove part is the salud, the negative. Salud otra vez. So I'm going to remove these guys. These guys are kicked out of the party. They were sneezing too much in class. Okay? And these are gone. So I've removed 2 sets of negative, or did I just, yeah, 2 sets of negative 3. Tamaya?
Why do you have to take out the
When, I needed that. Why do I need to take out the negative? Just think of this negative 2 right here. Since they're both negative, think about the negative of being removal. Okay? Think of that negative integer being removal of something with multiplication. Okay? So what is left? Who's left at the party? Who wasn't kicked out by the green group? The green man group. Raise your hand. Raise your hand. Sean, not Sean. Logan, do you know? How many? There are 6 remaining. Is that a positive or negative? Positive. And look what we wrote up here, so we know that we're right. There are 6 positive integers still chilling. Okay, we need to move a little bit. Now we have, quiet please, 6, not green, I want black. 6 groups of -2. So all I'm going to do is I'm going to take my negative and make 6 groups of -2. There's 1 group. 2, 3, 4, 5, 6. 6 groups of -2. If you both write out the sentence like I'm doing and write it out like that, there should be no reason for you to get any of these wrong tomorrow, and it's going to be such a quick check when we do our homework. Check our homework. And how many are left? Who's at the party still? Raise your hand. I have not heard from Haley today. How many are left at the party? -4. Think about how many integers we have in our at our party, in our map. How many negative integers do we have there? 12. So the answer is -12. So the answer is -12. So now we have number 4. Both integers are negative. So what do we have to create? Yes? So, well, yes, but we took notes on something. What do we need to do, Tamaya? Make a sea of zeros. Beautiful. And to know, it's going to be to remove. I'm going to zoom in. It's going to remove 4 sets of -3 integers. So in order to remove 4 sets of -3 integers, we need to create 4 sets of -3 zeros. So am I in red? Aha. So I have 1, 2, there's 1 set of -3. 2 sets of -3. 3 sets of -3. 4 sets of -3. But I have to create zeros. What was positive again? Was it? Okay. Now finally the action of remove 4 sets of -3. Let's bring in the green group. They're known for disposal. I'm getting rid of 1 group of -3, 2 groups of -3, 4 groups of -3. Whoops. 4 groups of -3. What did I? So I've kind of created some dinosaurs here. Who's still left at the party? How many? Brian, is it? Ryan, close. There are 12 positive integers left at the party. So the answer is 12. Positive 12. And something tells me I did that one wrong last period. Something doesn't seem right. Whatever. I removed 4 sets of negative 3. I really hope that you're writing what I have up here. Okay? I'll tell you when I don't want you to write something. I'll tell you when I don't want you to write something. Okay? You should be writing what I write, as I write, how I write it. This one is just like ones that we've done before. You don't need to do that one. This one is, wait a second, was 6 the one? Oh, no, sorry. That's the one I meant to do. This. It's all right. You're doing it in pencil, so it's okay. Smith number 5. Because those are your instructions to only have a red pen for checking work. Pencil is for everything else. So this one here, we are going to be bringing in 3 sets of negative 3. I'm just going to go ahead and write those really quick because this is similar to one of the examples I had before. That's a really good, I've been drawing some really good circles today, I tell you. Yes, Chase. What do you mean? No, because we're not there yet. So that means that rather than listening when we were doing stuff, you were just doing. And then also, hold on, and also, when we're working on it and you're done, you might get bored, and it's possible, depending on your focus, would be distracting to others. Good, let's keep it that way. And please stick with me. Now, here's one that is potentially going to cause trouble. We have a huge group that we're taking away. There are 2 ways to do this. I'm going to show you the long way, but before I'm going to remind you about the commutative property of multiplication. Remember the community? We can sit in any seat that we want to, but we're going to be still this class. So this can also be 2 multiplied by negative 9. And that situation would be we have 2 groups of negative 9 integers. But I'm going to do it like this to make sure that you guys know that we are going to be making, actually it could go either way. What do you want to do? It's going to be the same thing anyway. Do you want to make 9? Do you want to make 2 groups of negative 9 integers, or do you want to make, or do you want to take away 9 groups of positive 2? Okay, we're going to do the second one because it's harder. So I'm going to create nine groups of 2. 2, 3, 3, 3, 3, 3, 3, 3. Those are all positive. Okay. Then I have to create my negatives. I'm not going to put a negative sign in there because we're pressed for time. I've created, now I have to get out the green team. We are going to take away 9 groups of positive 2. So here's 1, 2, you're out of here. 3, you're out of here. 4, see ya. 5, adios. 6, peace out. 7, until tomorrow. 8, go away. 9, you're done. So we are left with how many that are chilling at the party now? There are negative 18 people still at the party. There are negative 18 people still at the party because we removed 9 sets of 2 positive integers. And Smith, the last one.